We offer several MolCube workflows, including system build, docking, and alchemical-free energy simulator. Today, we will introduce the workflow of alchemical-free energy simulator using membrane system. On the left side of the panel below, locate the MolCube workflow and click Quick Start. All workflow processes are displayed on the dashboard. Select Alchemical Free Energy Simulator with Membrane System and click Start. You will find information about Alchemical Free Energy Simulator with Membrane System. Before starting the workflow, please review this information for a better experience. Once you've reviewed the information, click Start. The workflow will begin, and you'll be prompted to enter the project title. Workflows may include multiple projects, therefore you can distinguish between the workflow title and the project title. After entering the project title, click Create. To start AFES, the first step is to load the protein you will use by reading it through the PDB reader. By default, the title of each step follows the workflow's predefined title, but you can modify or add to it as needed for convenience. After selecting the force field and required options for your project, click Submit. Once the submission is complete, the system will load the next step. In Step 2, enter the PDB ID or UniProt ID of the protein you want to use. If you are using a custom file, you can upload it directly or load a predicted structure generated from Boltz 2 or Protonix. After adding any necessary options, click Submit. After submission, the next step will be prepared automatically. In Step 3, review and edit the information about the selected protein. In this video, we will proceed using the default options, but for more detailed explanations, please refer to the PDB Reader demo video. In Step 5, check the generated structure and click Go to Next Step. In the Membrane Builder, the force field and project used in the PDB reader are automatically recognized. Select the membrane type and box shape, then click Submit. In Step 2, select the protein to align and choose the protein alignment options, then click Submit. In Step 3, configure the lipid composition. Set the box margin and packing options for the complex system, then select the desired lipids. In this video, cholesterol and POPC are used, but the library includes many other lipids. For more details, refer to the Membrane Builder demo video. After entering the ratio of the selected lipids, click Submit to proceed to the next step. In Step 4, review the positions of the lipids which are shown as dummy atoms and the box size, then click Submit to replace the dummy atoms with the selected lipids. To complete the bilayer structure in Step 5, you can modify the box and simulation options. However, note that only box shape, box margin, ion type, and ion concentration affect the output of the Alchemical Free Energy Simulator. Other settings will not influence AFES results. After configuring the necessary options, click Submit. Finally, in the last step, review the 3D structure of the generated membrane and click Go to Next Step to proceed. Once the process is complete, you will move to Ligand Reader and Modeler. If the PDB structure contains multiple reference ligands, select a reference ligand based on the native ligand. Then click to upload ligand SDF files to upload the ligands that will be aligned with the native ligand and click Submit. After submission, the system will process the ligands and prepare the next step. In Step 2 of Ligand Reader, select the force field to apply to the ligands. You can review the aligned structures in 3D, choose to exclude certain ligands from the uploaded list if needed, and download each structure individually for verification. When ready, click Submit. After submission, the system will advance to Step 3, where you can check the processing status of each ligand. Once confirmed, click Go to Next Step. Once the process is complete, you will proceed to the final stage of the MolCube builder. In the Alchemical Free Energy Simulator, select the desired free energy calculation program, method, and application. In this video, we demonstrate relative binding free energy calculations using GROMACS NETI. AFES automatically retrieves the previous project and applies the same force field used earlier. Click Submit. After submission, the system will advance to the next step. In Step 2, AFES automatically imports the ligand reader and modeler project, populating the target ligand and ligand force field details while allowing you to view the aligned ligands in 3D. After reviewing the structures, select the ligands to use for AFES and move them to the selected panel. Click Generate Morph Set to create morph sets from the selected ligands. At this stage, you can choose between two options: Closed, which recommends a minimal perturbation path based on clustering, and Radial, which generates radial perturbation paths from the reference ligand to all other ligands. Select your preferred option and click OK. Once confirmed, the Morph Set Builder will display the generated sets. In the Morph Set Builder, you can review all generated morph sets for each ligand force field. You can also add new morph sets using the Add Morph button, modify the start and end ligands by clicking on them, or delete any morph set using the DEL button. Clicking the Clustering button displays the clustering results of the morph sets in the list. By selecting a node, you can view the 2D structure of the corresponding ligand. If two ligands are unconnected, you can select them and click Add Edge to create a morph set between them. Conversely, clicking Del Edge removes an existing morph set. Using the Similarity Matrix button, you can review the similarity scores between all selected ligands. Clicking on a score displays the 2D structures of the corresponding ligand pair. After defining all morph sets to be analyzed, click Submit. Once processing is complete, the system will transition to Step 3. In this step, review the core indices highlighted in red for each morph pair, along with the perturbed regions shown without highlights. By default, selected core atoms can be excluded by clicking on them, but non-core atoms cannot be added to the core region. Once the core indices for all morph sets have been reviewed, configure the box, ion information, simulation options, and temperature settings required for ligand system building, then click Submit. After submission, the AFES system will be generated. At this point, you can download the project to run the calculations locally, but clicking Go to Next Step allows you to easily run the simulations using the MolCube simulator. Once the process is complete, the simulator interface will be displayed. In the MolCube simulator, you can configure the number of AFES trials, and the information for the method, force field, ion type, and temperature is automatically recorded. When selecting the ligand force field used for morph set generation, the morph sets associated with that force field are displayed. Choose the morph sets to calculate and click Submit. After submission, the simulation will start automatically. You can monitor the status of each stage, minimization, equilibration, and production for both the complex and the ligand. During the production stage, you can also view the average simulated time and average performance. It may take several hours. Once the calculation is complete, a download button will appear. You can either download the results or click the Submit to Analyzer button to proceed to MolCube Analyzer for free energy analysis. After the simulations are completed, click the Simulator to Analyzer button to proceed to MolCube Analyzer for free energy analysis. Once the analyzer is loaded, you can select the morph sets you want to process. MolCube Analyzer allows you to easily obtain delta-delta-G or delta-G values using the results generated from MolCube Simulator. Select the morph sets you want to analyze, then click Run on AWS to start the calculations. Once the analysis begins, the status will change from pending to running, and you can track the progress of each morph set in real time. When the calculation is complete, the table will display the delta-delta-G or delta-G values, and you can click Download to retrieve the analysis results.